To understand what loneliness does to the brain, you first need to understand what the brain actually is, not in the philosophical sense. In the practical, biological, evolutionary sense, the human brain is not primarily a thinking machine. It is not designed first and foremost to solve math problems or write poetry or contemplate the universe. It is a survival machine. Every single structure inside it, every fold, every neuron, every chemical pathway, exists because at some point in our evolutionary history, it helped a human being stay alive long enough to pass on their genes. And for the vast majority of human evolutionary history, hundreds of thousands of years, staying alive was a group project. You did not survive alone. No single human being, stripped of tools, technology, and community, can reliably survive in a natural environment. We are physically weak compared to predators. We are slow. We don't have claws or venom or natural armor. What we have is each other. Social cooperation, collective memory, shared labor. These are the things that kept the species alive, which means the brain, over hundreds of thousands of years, evolved to treat social connection not as a luxury, but as a biological necessity, as essential as food, as essential as water, as essential as warmth. And what does the brain do when it detects that a biological necessity is missing? It sends an alarm. The moment you become socially isolated, the moment the brain detects an absence of meaningful human connection, a specific neural network activates. It is called the salience network, and its job in simple terms is to detect threat. The same network that fires when you hear a loud noise behind you at night. The same network that activates when you see a spider on your arm. The same network that floods your body with adrenaline when your car almost slides off an icy road. That network. For loneliness, this was one of the most surprising discoveries in modern neuroscience. For a long time, scientists assumed that loneliness was processed primarily in the emotional centers of the brain, the regions associated with sadness, grief, social pain, and those regions are involved. But the first response, the primary, automatic, neurological response to social isolation is a threat response. Your brain, when it detects loneliness, does not first feel sad. It first feels danger, and this makes perfect evolutionary sense. If you were separated from your group in the ancestral environment, if you found yourself alone on the savannah, away from the tribe, that was not a neutral situation. That was a life-threatening situation. Predators could find you. You couldn't sleep safely. You couldn't hunt effectively. You were, in the most literal possible sense, in danger of dying. So the brain evolved a system to motivate you, urgently, powerfully, uncomfortably, to rejoin the group as quickly as possible. That system is loneliness. The pain of loneliness is not an accident. It is not a flaw in the design. It is the design. It is the evolutionary alarm bell screaming, "Get back to your people before something kills you." In the first hours of isolation, this alarm is subtle. You might feel restless, slightly anxious. The brain starts scanning the environment more aggressively, looking for social cues, for faces, for voices. You find yourself checking your phone more often, thinking about people, replaying conversations. The social radar, as neuroscientists call it, cranks up its sensitivity. This is the brain doing exactly what it's supposed to do, detecting the absence, sending the signal, pushing you toward reconnection. The problem is what happens when reconnection doesn't come. If the first hours of isolation are about alarm, the next phase, roughly hours 12 through 36, is about adaptation, or rather a deeply dangerous attempt at adaptation. The brain is extraordinarily plastic. It rewires itself constantly in response to experience, to environment, to repeated input. This neuroplasticity is one of the most remarkable features of the human mind. It's what allows you to learn languages, recover from injuries, develop new skills. But neuroplasticity is a tool, and like any tool, it can be used to build things or to destroy them. It all depends on what input the brain is receiving. When isolation continues past the first hours, when the alarm system fires repeatedly and nothing changes, when the brain keeps scanning for social connection and finding none, the brain begins to adapt to the perceived new reality. And the first adaptation is one that researchers at the University of Chicago, led by neuroscientist John Cacioppo, identified as perhaps the most counterproductive thing the brain can do. It begins to perceive the social world as more threatening. Here's how it works. The threat response system, activated by loneliness, begins to bias the brain's perception. Specifically, it begins to make the brain hypervigilant, excessively sensitive to potential social threats, to rejection, to criticism, to ambiguity in other people's behavior. In practical terms, this means that after prolonged isolation, when you do encounter another person, your brain is more likely to interpret a neutral expression as hostile, more likely to read a casual comment as a slight, more likely to anticipate rejection before it has any evidence that rejection is coming. This is called hypervigilance to social threat, and it is one of the most well-documented neurological consequences of loneliness. And here is the tragic, cruel irony at the heart of it. The brain's attempt to protect you from social pain by making you more alert to it actually makes you worse at connecting with people. It makes you more defensive, more guarded, more likely to misinterpret neutral or positive social interactions as hostile, which leads to more conflict, more withdrawal, more isolation. The loneliness deepens the very mechanism that makes loneliness harder to escape. It's a trap, a biological trap, built by evolution, that once it closes, becomes increasingly difficult to open from the inside. During this same window, hours 12 through 36, researchers have observed changes in the autonomic nervous system. The balance between the sympathetic nervous system, which governs the fight or flight response, and the parasympathetic nervous system, which governs rest and recovery, begins to shift. In connected people, the parasympathetic system is generally dominant during rest. The heart rate is stable. Breathing is slow. The body is in a state of relative calm. In isolated people, even during rest, the sympathetic system remains partially activated. The body stays in a low-grade state of alert. Heart rate variability, one of the most reliable markers of cardiovascular health and nervous system regulation, begins to decrease. Cortisol, the primary stress hormone, begins to rise. And cortisol, when it stays elevated, is extraordinarily damaging. It disrupts sleep. It impairs memory consolidation. It suppresses immune function. It increases inflammation throughout the body. It damages the hippocampus, the part of the brain most critical for memory formation and emotional regulation, over time eroding its ability to function normally. 36 hours in, your brain is not the same brain it was when the isolation began. Not dramatically different, not visibly different to an outside observer, but measurably, chemically, structurally different. The alarm is still ringing, and now the building is starting to change to accommodate it. This is where the research becomes extraordinary. 72 hours. 3 days. In 2021, a team of researchers at MIT, led by neuroscientist Livia Tomova, conducted what became one of the most remarkable loneliness experiments in modern science. They took participants and subjected them to 10 hours of complete social isolation. No communication, no eye contact, no social media, no interaction of any kind. Before and after, they scanned their brains using functional MRI, looking at patterns of neural activation. What they found surprised everyone. When isolated participants were shown images of social interactions, people laughing, people embracing, groups of friends together, a specific cluster of neurons in the midbrain lit up. Not in the emotional processing centers, not in the reward pathways associated with pleasure, in the substantia nigra, the same region that activates in response to food after fasting, the same region that drives the most primal, urgent biological cravings. The brain, after even 10 hours of isolation, was treating social connection the same way a starving person treats food. Not metaphorically, not poetically, neurologically, biologically. The hunger for connection was activating the same ancient, fundamental craving circuits as the hunger for calories. Now extrapolate that to 72 hours. At the 3-day mark, something shifts in the brain that researchers have only recently begun to fully document. The threat response, the hormonal disruption, the hypervigilance, these continue and intensify. But something else begins to happen, something that takes the science from concerning to genuinely alarming. The brain begins to alter its processing of time and self. This is subtle but profound. Studies of people in prolonged isolation, solitary confinement prisoners, solo sailors, Antarctic researchers, consistently report a strange distortion of subjective experience. Time becomes unreliable. The boundary between self and environment becomes less distinct. Memory starts to blur. Not in the sense of forgetting facts, but in the sense that the continuous narrative of the self, the feeling of being a coherent person moving through time, begins to feel less stable. Why? Because the brain constructs the sense of self, in large part, through social feedback. Through other people reflecting you back to you, through conversation, through recognition, through the constant low-level social mirroring that happens every time you interact with another human being. This is not philosophy, this is neuroscience. The default mode network, the brain system responsible for self-referential thought, for the sense of personal identity, for autobiographical memory, is deeply intertwined with social cognition. When social input disappears, the default mode network loses a primary source of calibration, and without that calibration, its outputs become strange, fragmented, unreliable. People in prolonged isolation begin to hallucinate social presence. They hear voices. They imagine conversations. They experience a powerful, almost overwhelming urge to speak aloud, to narrate their own experience to an imaginary audience, because the brain is desperately trying to recreate the social input it is missing. This is not madness. This is the brain doing the only thing it knows how to do, trying to solve the problem of isolation with the tools it has. When no real social connection is available, it manufactures a simulation, a ghost of connection, because even a simulated connection, the brain seems to believe, is better than none at all. At 72 hours, the immune system has also begun to respond. Studies have found that prolonged social isolation triggers an upregulation of pro-inflammatory genes, the genes that produce inflammation throughout the body. This is part of the same ancient threat response system. When the ancestral brain detected danger, including the danger of social isolation, it primed the immune system for injury. Inflammation is the body's response to physical damage. If you're going to be hurt by a predator, you need that system ready to go. But chronic inflammation, inflammation that fires not in response to actual injury, but in response to a psychological state, is one of the root causes of cardiovascular disease, diabetes, Alzheimer's disease, depression, and cancer. The brain trying to protect you from the danger of loneliness is in the process creating the biological conditions for a dozen different ways to die young. 3 days is a window. It's where the acute changes begin. But for millions of people, the isolation doesn't end after 72 hours. It goes on for months, years, sometimes decades. And when it does, the changes that began as reversible adaptations become something else entirely. John Cacioppo spent 30 years studying loneliness, arguably more time and rigor than any other scientist in history. Before his death in 2018, he and his colleagues at the University of Chicago produced a body of research that fundamentally changed how we understand social isolation. His findings were staggering. Chronically lonely people, those who report persistent, significant loneliness over years, show accelerated cognitive decline. The hippocampus shrinks faster. The prefrontal cortex, responsible for decision-making, impulse control, and emotional regulation, shows reduced activity. Executive function, the ability to plan, to reason, to regulate behavior, degrades measurably faster in chronically lonely individuals compared to socially connected people of the same age. Put simply, loneliness makes you think worse. And over years, it can contribute to the onset of dementia at earlier ages. But perhaps the most dramatic finding, the one that produced the most headlines, the most shock, the most disbelief when it was first published, was this: chronic loneliness is associated with a 26% increase in the risk of early death. Not psychological death, not social death, physical, biological, cardiac death. Dying younger than you would have if you had been more connected, but 26%. For context, obesity is associated with a roughly 20% increase in mortality risk. Chronic loneliness is more dangerous, statistically, than being obese. Smoking 15 cigarettes a day, a habit we have spent decades as a society stigmatizing, taxing, warning against, is associated with roughly comparable mortality risk to chronic loneliness. We have never run a single public health campaign about loneliness. There is no Surgeon General's warning on the side of a solitary lifestyle. There are no advertisements, no school programs, no cultural messaging at scale telling people that the quiet absence of real human connection is, in terms of sheer body count, one of the deadliest conditions in the modern world. Why not? Partly because loneliness is invisible. You cannot see it on a scan at your annual physical. It does not show up in blood work the way cholesterol does. It does not produce a symptom specific enough to trigger a diagnosis. It hides behind depression, behind anxiety, behind substance use, behind the 10,000 other things that bring people to doctors' offices. And partly because modern culture has done something perverse. It has reframed isolation as freedom, as independence, as strength, the lone wolf, the self-made person, the one who doesn't need anyone. We have, at a civilizational scale, romanticized the exact condition that is quietly killing people at scale. Social media made it worse, not better, despite everything it promised. Because social media is to real connection what a photograph of food is to a meal. It looks right, it feels almost right, but it does not nourish. The brain's connection craving systems are not satisfied by passive scrolling, by likes, by curated highlight reels of other people's lives. They need eye contact, they need physical proximity, they need the full, rich, embodied experience of genuine human presence. A 2017 study found that people who used social media for more than 2 hours a day reported feeling twice as lonely as people who used it for less than 30 minutes. The platform designed to connect us was, for many, deepening the very disconnection it promised to solve. Here is the other side of the science. The side that contains something close to hope. If the brain is so profoundly shaped by isolation, it is equally, powerfully shaped by connection. The same neuroplasticity that allows loneliness to rewire the brain toward threat and hypervigilance also allows genuine social connection to rewire it back, and in some cases, to rewire it in directions that produce extraordinary resilience, well-being, and even measurable physical health benefits. Oxytocin is perhaps the most famous molecule associated with social bonding, often called the love hormone or the bonding chemical. Oxytocin is released during physical touch, during meaningful eye contact, during genuine conversation, during moments of trust and vulnerability between people, and its effects on the brain and body are remarkable. Oxytocin reduces cortisol. It dampens the activity of the amygdala, the brain's threat detection center, directly counteracting the hypervigilance that loneliness produces. It enhances the function of the vagus nerve, improving heart rate variability and parasympathetic nervous system regulation. It reduces inflammation. It enhances immune function. It improves the quality and restorative depth of sleep. Every single one of those things is the precise opposite of what loneliness does to the body. Connection is not just emotionally good for you. It is pharmacologically active. It releases molecules that have measurable, documented, clinically significant effects on virtually every major system in the human body. The Harvard Study of Adult Development, the longest-running study of human happiness and health ever conducted, following hundreds of people across 8 decades of their lives, found one consistent, overwhelmingly dominant predictor of both happiness and physical health in old age. Not wealth, not career success, not intelligence or discipline or healthy eating habits, the quality of your relationships. People who reported warm, close, trusting relationships in midlife were healthier at 80 than people who had reported isolated, conflictual, or superficial relationships, even controlling for every other health variable. Their memories were sharper. Their immune systems were stronger. Their bodies aged more slowly by almost every measurable metric. The people who had cultivated deep connection were, in the most literal biological sense, more alive. And this points to something that the neuroscience keeps returning to, in study after study, from decade after decade of research. The human brain is not designed to be alone, not occasionally, not temporarily in response to crisis or circumstance, but chronically, by default as a lifestyle. We are a social species in the most fundamental cellular, neurological meaning of the phrase. Our brains are tuned to the frequency of other people. They calibrate themselves, regulate themselves, maintain themselves through the constant exchange of presence, attention, recognition, and care. When that exchange stops, the brain does not simply feel sad. It begins to break. So where does this leave you? Maybe you recognized yourself somewhere in this video. Maybe you thought about the last time you had a conversation that felt truly real. The last time someone looked you in the eyes with genuine attention. The last time you felt fully, deeply known by another person. Maybe that was yesterday. Maybe it was a very long time ago. The science doesn't judge either answer. But it does insist on being taken seriously, because one of the most important things that Cacioppo's research established, and this is crucial, This is the thing that often gets left out of the conversation about loneliness, is that the solution is not simply more social contact. It is better social contact. More meaningful social contact. Quantity of relationships has almost no correlation with health outcomes. What predicts health? What predicts cognitive function, immune strength, cardiovascular resilience, psychological stability, is the quality and depth of connection. The feeling of being genuinely known, genuinely valued, genuinely part of something larger than yourself. You can be surrounded by people and be profoundly lonely. You can have a small handful of deep, trusting relationships and be profoundly connected. The brain does not count faces. It measures depth, which means the path forward is not about going to more parties, accumulating more followers, filling your calendar with more obligations disguised as socializing. It is about the much harder, much more vulnerable, much more rewarding work of allowing yourself to be truly seen, of having the conversation that goes beneath the surface, of admitting that you're struggling, that you're uncertain, that you're scared, to someone who can receive that and stay, of investing the time and attention that real friendship, real partnership, real community requires, of choosing depth over breadth, quality over quantity, presence over performance. The neuroscience of loneliness is ultimately the neuroscience of what it means to be human. We are not individuals who occasionally choose to connect. We are fundamentally relational beings who sometimes tragically find ourselves cut off from the connection that is as necessary to our survival as oxygen. The brain knows this. Every alarm it sounds, every hormone it releases, every desperate hallucination it generates in the dark to simulate the presence of another person. These are not signs of weakness. They are signs of a brain doing exactly what it was designed to do, reaching urgently and persistently toward the thing it was built to have: other people. Loneliness is not a personal failing. It is a biological signal, a distress flare fired from the most ancient parts of your brain, telling you something you already know at the deepest level of your being. You were not built for this. You were built for something else, something warmer, noisier, messier, and infinitely more sustaining. You were built for the extraordinary, irreplaceable, neurologically transformative experience of being genuinely present with another human being. The 72 hours are a window, but every moment is a door. And somewhere right now, there is someone on the other side of it, also waiting, also reaching, also hoping that someone will simply show up and say, "I'm here. Tell me how you are. I'm actually listening." That conversation, that one, small, ancient, human act, is medicine, and the brain has known it all along.